So, 3 pieces, yeah? Well, really 2 pieces and then a question. Firstly, y is a function, right? So when you're differentiating this, it's not going to simply be 1 on y, okay? Because the fact that they're telling you y is really a function of x means they want you to differentiate with respect to x, okay? Which is actually what we normally do, okay? So, let's give this a go, shall we? This is the first part, the clue. Differentiate log of y, okay? Now, if y is just a function, right? We're taking log of a function. This is chain rule. What does it look like? Yeah, that's right. Y dash on y. We're used to saying f dash on f, right? But it's just labels, yeah? Now, just to make it clearer, because, you know, I try to avoid using dashes and that kind of thing because it's ambiguous, I'm going to write y dash in its full form. dy and dx all over y. Okay, is that alright? Maybe I should chuck some brackets there, just to be obvious. Okay. Alright, great. So, there's a clue, which turns out to be not very cluey. Like, I don't even have anything even remotely resembling that. At least not yet. So what do I do? What should I do here? What direction would you go in? They've given you this clue, right? Or I've given you this clue. What would you do, Seb? Okay. So this is actually usually where questions begin, right? But they're sort of expecting you to try and work that out given this clue, right? This is the function and therefore, what would you do with this? Okay, now, if I want to differentiate this, you've got a problem because it's not x to the power of a number, it's not to the power of a constant, so I can't just use the power rule. And it's not a constant to the power of x, so I can't just use the exponential rule, right? So that's why this sort of chain rule comes into play. Because our clue is in terms of logs, what do you think would be the most natural first step? That's right, well, you've got 2 options. Number 1, it's an initial equation, so I can rewrite it as a log equation, which I guess would look like this. Log base x of y is equal to x. Yes? That would be fine. Okay? And you can get the answer out of this. But in this case, it actually adds a couple of lines for you. And we should know that there's a better direction to go in, a more efficient one, because of the clue they gave us, right? So even though this will get us there eventually, I'm going to start with this line, and I'm going to take natural log of both sides. Okay? Natural log. Is that okay? That'll give me natural log x to the x. Okay? Now I wonder if the cogs are turning. Can you see why taking the natural log here is a good idea? It sort of starts to head you in the direction of solving this weird, insoluble problem. Okay? Because this here I can manipulate, right? I can get that troublesome power out of the power. How do I do that? Yeah, this can become the coefficient. So remember your log laws, right? These are exactly the kinds of questions that will appear because they'll test if you remember your log laws, right? We spent a whole topic on it. So that's x log x, and this is log y. And now you can see, again, the clue comes in. I want to get the derivative of y. So this is actually, it's kind of like implicit, isn't it, right? If I differentiate the left-hand side, I'm going to get this. I already know that because I just worked that out, right? dy on dx all over y. You differentiate the right-hand side, and that's a product, right? Product. So vu dash plus uv dash. V is log x. U dash is just 1. U is x, and v dash is 1 over x. So x times 1 over x is just 1. Okay. Okay, so we're almost there. We wanted the derivative of x to the x, right? So I want to make dy dx the subject. So I guess all I have to do is put that y across. But before I write that, I know what y is. I actually introduced it, right? So therefore, I'm going to get rid of all the y's and say dy dx is x to the x log x plus 1. Okay? So you see, they can give you all kinds of questions, like weird ones that you're not expected to know if they give you the right kind of clue in the first place. Okay?